Okay, so good morning once more. I hope you enjoyed that theory lesson on VLAN routing. So right now, we'll look at how to configure VLAN routing. As you saw in the first lab, one of the problems with VLANs is that it can isolate users. But sometimes you still want users to be on different VLANs and be able to communicate. So when you're not using hybrid ports, you can also use VLAN routing. You can introduce a layer 3 device to be able to route VLAN traffic within your subnetworks. So the learning objectives for this particular lab is to establish a trunk interface for VLAN routing between the switch and the router, to configure sub-interfaces on a single physical interface. So we're going to create sub-interfaces on the router, and also to enable ARP messages to be broadcasted between VLANs. So there's a command for that that is going to enable ARP messages to be broadcasted between VLANs. As you know, layer 3 devices simply drop ARP broadcast packets and any other broadcast packets for that matter. But we can configure a layer 3 device interface to be able to forward ARP broadcast messages between VLANs. Okay, so this is how our topology looks like. Generally, excuse me. Generally, in this topology, R1 and R3 are actually simulating end devices. Then R2 is simulating our router, the router in which we are going to configure sub-interfaces. So we are going to divide the sub-interface G/0/0/1 into .11 and .13. So that is what we call sub-interfaces, and assign them IP addresses. Then we have our switch here, and in this particular switch, we are going to create two VLANs, VLAN 4 and VLAN 8. So we are going to add the interface, this one G001 that is connected to R1 to VLAN 4, and this interface G003, we are going to add it to VLAN 8. So generally, that is what we are going to do. And now, through configuring sub-interfaces here, we should be able to make R1 and R2 communicate via the router here, R2. So what really is going to be happening is, if R2 wants to communicate to R3, the frame is going to be sent there, then to the router, then back to the switch, then to this guy. So they are not going to communicate through the switch directly. So really, that is the purpose of this particular lab. Okay, so this is the topology that I want us to use. So instead of R1 and R2, I've replaced them with PCs. So that's the only difference that I've made. Otherwise, everything else remains the same. So that's the only difference that I've made. So we're going to add PC1 to VLAN 4 and PC3 to VLAN 8. And these are the IP addresses that we are going to configure PC1 and PC2 with. Okay, so let's look at step 1. So step 1 is preparing the environment. Generally, we are supposed to assign an IP address to R1. And also assign an IP address to R3. So in our topology, that is PC1 and PC3. So I think we can just do that very fast. So PC1, we assign it the IP address 10.0.4. Let me confirm .1, I think. Oh.
.1.
.1, okay. .1. Thank you. Then we go ahead and do the mask 255.255.255.0. So we apply. Then we come to PC3, 10.8. So we do 10.8, 10.0, sorry. 10.0.8 dot what for PC3 dot 1 PR?
Yeah.
Okay, so dot 1. Then we do 255 to 255. Then we apply. Here, as you can see, PC3 and PC1 are on different networks. So already we cannot be able to ping between them for that fact that they're on different networks. So if we ping dot 1, we should be unable to ping dot 1 because PC1 and PC2 are on different networks. But if we change this, for example, to 4, so that they're on the same network, and maybe PC3 to dot 3, if we change them like that, so let's just change them like that for the meantime. If we do a ping to PC1, then the ping should be successful. So let's just leave it at that in the meantime. Now, the next thing we are supposed to do is to create the VLANs. We now configure the VLANs. Let's keep step 4 just a little bit on VLAN routing. And it's not step 4, it's step 3. Step 3, yeah. We need to establish the two VLANs on S1. So VLAN 4 and VLAN 8, and add the respective interfaces to their respective VLANs. So that is what we want to do here. And we're also going to create a trunk port between the switch and the router, and allow VLAN tagged frames with a VID of 4 and 8 to pass. So that is what we want to do now. So let's go to switch 1. So the first thing we do, of course, is to rename it to S1. Let me just boom this up. Okay. Okay, so now we want to create VLAN 4 and VLAN and VLAN 8. So other than creating in batches, we can also create one by one like that. So VLAN 4, then we also create VLAN 8 like that. So then I can quit. So after we do that, now we can go into the interface gigabit Ethernet 0/0/1 that is connecting PC1. Then we do port link type. So this is an access port because it's connecting to an end device. Then after that, we add it to VLAN 4. So port default VLAN 4 like that. So after we are done with that, we go into interface gigabit Ethernet 0/0/3. Again, this is port link type access. Then we also do port default VLAN 8. So if we quit and we display VLAN, we should be able to see that we have VLAN 8 and VLAN 4, and we've added PC1 to VLAN 4 and that PC to VLAN 3. So the reason as to why I had changed this IP address is so that I can show you after we've added them to different VLANs, even though they are within the same network segment, the ping is not going to work. The ping is going to fail because they're on different VLANs. So we already did this. in the previous lab. So let's return this to 8.1 on PC3. So we apply. So the next thing we want to do is to make this particular port a trunk port on the switch. So let's go ahead and get into interface 002. So we want to do the command to ensure that this now is port link type is a trunk port, trunk. So this one is a trunk. Then we want to allow VLAN frames, support trunk, allow pass. We allow VLAN 4 space 8. So we are not allowing all, we are just allowing frames that have been tagged with the VID of 4 and 8 to be able to pass through as tagged frames on the trunk port. So once we are done with that, then we finished every configuration that we need to do within the switch. So now let's go to the router. So on the router, that is now step number 4. We configure VLAN routing through sub-interfaces on R2. So we are going to divide that interface 001 to 001.1 and 001.3. Then after we divide them, we also assign them an IP address. We assign them an IP address. Then we use this command, .1q termination, VID4. Can someone remind us? How did I explain about .1q termination command on the theory class? Any volunteer? What does this command do?
I think you said it just changes the packets from being in untagged state to tagged state.
Exactly. So it's exactly something like that. So it simply means this subinterface, when it receives any packet with a VLAN ID of 4, it's supposed to remove that VLAN ID, forward it through the routing table, then before releasing it to the next hop, it is supposed to tag that particular packet again with a VID of 4. So that is what it does. Then this is the command to enable broadcast, ARP broadcast packets or frames to be shared within VLANs. So ARP broadcast enable. So that is exactly what we are going to do on R2. Okay, so let's do it. So we begin by renaming this to R2. Then how to create a subinterface? You simply do int gigabit Ethernet 0/0, then 1.1, like that. So when you do that, you're going to get into the subinterface 1.1. Let me stop. Okay. So let's now assign this an IP address. So IP address, so here, 10.0.4.254. So 10.0.4.254.24. So that's the first thing we do. Then the next thing we do is the .1q termination. So .1q termination for 1.1, we want it to be able to accept frames with a VLAN ID of 4 and do the necessary. After that, we're also supposed to do ARP broadcast enable. ARP broadcast enable, like that. So after we are done with that, that's the only thing we need to do. Now we go to G0/0 the other subinterface .3. Then on .3 we also assign it an IP address. So 10.0 .8.254 24. Then .1q termination VID 8. So we want it to accept frames with a VID of 8. Then we also enable ARP broadcast. So ARP broadcast enable. Okay, so once you do that, you will expect now that PC1 and PC3 should be able to ping each other. So let's try it. So let's ping PC3, so 10.0.8.1. So why are we still not able to ping PC3? So for frames or packets to be forwarded to the router, you need to set the router sub interface as the next hop. You need to as the gateway. So this particular sub interface on PC1 should be set as the gateway. So here we're supposed to come to the gateway here and do 10.0.4.254 like that. So we're supposed to apply. Then for PC3, the gateway for PC3 is this sub interface, this one 1.3. So we also set that gateway, which is 10.0.8.254. So that's the gateway. So if we do apply, then now the ping between PC1 and PC2 should be able to work. So now if we ping, you see it works. So generally, that is all that we were supposed to learn on this particular lab. So generally what is happening here, as I explained earlier in the topology, anytime we want to talk to PC3, that particular packet has to be forwarded via the VLAN trunk, via the trunk to the router. Then the router is going to reroute it, then forward it to PC3. So I hope you've been able to see that and now you appreciate it. Anyone with a question? Yes.
What like how many VLANs can you configure like on that R2?
How many VLANs can you
configure to be hosted by that R2? Like, can you have like it has a number like 8, like the one we are doing the trunking? Like this is the maximum number it can hold, something like that.
In terms of the number of VLANs you can create,
Yes.
VLANs are created on the switch. I'm forgetting what's the number, by the way. Is it 4096? I think it's 4096. Yes, 4096, 4096. Except VLAN 1, which is the default, so you cannot create VLAN 1, and you can also not create VLAN 4096. So you can create VLANs between VLAN 2 to 4095. So about 4094 VLANs. So okay, you can create all those VLANs in your switch. Okay, sawa sawa.
Now, just like we are doing, we have done the VLAN on the that switch.
Yes.
So like now, since we are using a layer 3, that is the router. Now that layer 3, how many can it hold of this other, the layer 2 to layer 3? Is there a number also? It's just
I don't know. Are you asking the number of sub interfaces that you can create on the router?
Sure.
Something like that, right?
Yes.
Okay, I'm not sure if there's a maximum number of sub-interfaces. Maybe something that you can try and Google around.
Okay.
Yeah, I'll also try, but I'm not sure the maximum number of sub-interfaces that you can create on a single physical interface.
Fine, my last one. Is there any preference you're using the .1 and .3? Can't you like the interface G00
Yes, yes. We are simply using .3. We were using .3 because this is PC3. So just for ease of understanding and explaining. And we're using .1 because this is PC1. But you can use .1, .2, .3, .4, .5. I don't know up to how many. I don't know the max, but hakuna preference really.
Sawa, asante.
Okay.